we're looking at the idea of dependent and independent variables. What I'm trying to find is, I'll have two variables, but I really can't know one without knowing the other. If I don't know one, I can't figure out the other one because that one depends on the first, which would be the independent. So if we break these down into parts, it's pretty easy to sort of put them together and see what's independent and dependent. So the first thing they say is that a shirt costs $T. So I can easily say the cost of the shirt would be represented by the letter T. A pair of jeans is $35 more than a shirt. So if I think about the cost of the jeans, it's more than the shirt. If the shirt is T and the jeans are $35 more, then I would call the entire cost of the jeans the shirt's cost T plus $35. They said write an expression to show the pair of the jeans in terms of G. Well, I think they mean T. That's the only thing that would make sense. In terms of T. So we could call the jeans a T plus 35 because it's the cost of the jeans, or the cost of the shirt, which is T, plus another $35. But then they go on to say that the cost of the jeans is actually U dollars. We just said the cost of the jeans was T plus 35. But if I want to know just the cost of the jeans and call it U, I know that it's the cost of the shirt plus 35. So what I now know is to find the cost of the jeans here, I need to know the cost of the shirt and add 35 to it. So when I think about independent and dependent, the dependent variable is clearly U. I can never know the cost of the jeans unless I know the cost of the shirt first. The cost of the shirt, T, would be fully independent. It's U that depends on T. It's the cost of the jeans that depends on the cost of the shirt. For this one, we can take a look at this one and say, break it down into parts and say Joseph finished the test in G minutes. So I know that Joseph, he was done in an amount of time that we'd call G. And then Catherine, she finished the exact same test in less time. So Catherine, it was the same G, but it was without 8 minutes. So the amount of time she actually has here is this G without 8 minutes. So write an expression for the number of minutes it took her in terms of G. Well, I know it's that same G that Joseph took, just without 8 minutes. Then they go on to see that Catherine actually did it in V minutes. Well, if Catherine wants her own variable, Catherine's amount is Joseph's amount minus 8. If I want to know Catherine's amount, I got to know Joseph's amount first. So when I think about the dependent variable, V, Catherine's amount, totally depends on what Joseph's was. The independent was Joseph's, which we call G. Why don't you try this one and see how you do? So they tell us here that Winston is N years old. And his father is 3 times as old. So I know that his father is actually going to be 3 N's. So I know Winston is N, his dad is 3 times older, or 3N. And they say, okay, write an expression for Winston's father's age in terms of N. Well, we just did that. Winston's dad is 3N. It's 3 times older than him. Then they say his dad's S years old. Oh, that's easy. So I know his dad, S, is 3 times whatever Winston is. So now I have like one depending on the other. I can never know dad's age unless I know Winston's age first. So I think the dad's age, S, fully is dependent. It depends on Winston's age. Winston's age, N, is fully independent. Arthur paid B dollars for 5 pair of socks. This one's tricky, so let's try this one together. Arthur paid B dollars for 5 pairs of socks. So here's what I know. The full amount that Arthur paid was B for 5 pairs of socks. So each of these sections represents a pair of socks. So write an expression for a single pair of socks. Well, if all the socks were B, then each of these are 1/5 of a B, or B divided by 5. So each pair of socks is 1/5 of a B because the B was the full cost. Then they go on to say each pair of socks is K. Well, we just said each pair of socks was 1/5 of a B. So I know that K, the cost of a single pair of socks, is 1/5 of the total of the socks. State the independent and dependent. K, the cost of each pair of socks, is fully dependent upon whatever it costs for all those socks together. K fully depends on B in this case. When we talk about dependent and independent variables, what we're trying to figure out is which variable stands on its own and which one do you need to figure out another one, and which one's the dependent one because it depends on one or another. Usually what I like to do is set them up using bar models and make some decisions after that. So the first one says the height of a table is R meters. So I know that the height of the table, if I put the table here, I know the table is R meters. And now that table is twice as tall as the chair. So if I thought about the chair I would call half of an R. If the table's R and it's twice as big as the chair, and then the chair's got to be half of an R. They then say that write an explanation for the height of the chair in terms of R. Okay, so I know that the chair is 1/2 of an R, which makes sense. But then the next question they say, the height of the chair is T meters. Well, can it be half of an R and T at the same time? Yeah, it can be its own thing, T, but I can only figure out that T by knowing it's half of an R. So now I have an equation that relates T and R. I can't figure out T until I know what R is, which leads me here to independent and dependent. The dependent variable is T. I can never figure out that T until I know the R first. I can't figure out the height of the chair, T, unless I know how big the table is. I'll take the table's amount and divide it by 2. So I know that the dependent variable is T. It totally depends on R, and we would say that R is independent and stands alone.